Proportionality and similarity, proportionality and similarity, Euclidean Geometry, grade 12 examination questions. So we are just giving examples on how to answer Euclidean geometry questions. In this section, we are particularly paying attention to proportionality and similarity, giving you an example of what to expect in an examination situation, mathematics paper 2. So it might be nice to stop this video and do the question, answer it. When you are done, then go through the answer that we provide and listen to the explanation that we give and see if your answer is correct. You need to be able to be in a position where you can answer it yourself. You can connect the relationship with the relationships yourself and be able to produce the right answer. Okay. All right, let's have a look at how to answer this particular question. The key part, like I always emphasize this, the key to answer a geometry question lies in understanding what they describe about the diagram. The information provided carries with it some hints and some leads that can link you to the theorems or to the concepts that are needed for you to answer that particular question. So let's have a look at what we have here. There isn't much, but the good thing is that whatever you are given is enough to answer the question that you are answering. Now I've got line BD perpendicular to AC and I have line DE perpendicular to AB. Now if we look at this diagram, we can see that the angle at B and the angle E1, they are equal to each other, and them being equal to each other gives us reminds us of the idea of corresponding angles, making the lines BC and the line ED parallel to each other. Now, we have been led two parallel lines. What do we know about parallel lines? We know about corresponding angles, and that means the value of angle C and D1 are equal to each other. They are both equal to X because they are corresponding angles. We also know about alternate angles. Alternate angles are equal. So that means the value of B1 and the value of angle D2, they are equal to each other. Now, we can find the value of B2 using the idea of angles in a triangle add up to 180 degrees. In triangle BCD, the value of D3 is 90, the value of C is X. So if we say 180 minus 90 minus X, that will give us the value of angle B2. It is 90 minus X. Because B2 is equal to D2, it means D2 is also 90 minus X. Now shift your attention and go to triangle BED. E2 is 90 degrees, angles on a straight line, and we have just discovered that D2 is equal to 90 minus X. We can calculate the value of angle B1 using the idea of angles in a triangle add up to 180. So if we simplify that, it gives us B1 is equal to X. Now we can find angle A using the same idea, angles in a triangle add up to 180. Now by so doing, I have basically expressed all the angles that are in this diagram. We started with identifying angle B and angle E1 as equal, leading us to parallel lines leading us to alternate angles and corresponding angles, and then combined with angles in a triangle add up to 180. The diagram has been completed. Now we can put up our answer. Number 1, we need to prove that triangle BDA and triangle CDB are similar to each other. Now, I normally want to specify which angles I'm looking at. In triangle BDA, BDA. At point B, the angle is B1. At point D, the angle is D1 plus D2. Then at angle A is the whole angle. In the next triangle, CDB, at D, we have D3. Then at B, CDB, we have B2. So similarity means you look at the first letter, angle A, and you look at the second one, angle C, and you check in your diagram, are those two angles equal or not? And you must give a reason why you say they are equal if they are. Then we look at the next angle, the angle at D and the angle at D. So it's angle D1 plus D2, this whole angle here, versus angle D3. And we can see that they are both equal to 90 degrees, therefore they are equal. Then we look at the last one, angle A versus angle B2. Those ones will automatically become equal. Once you get two pairs of angles that are equal, the third one will become equal because of angles in a triangle. They add up to 180. So this is my answer put together. B1 is equal to C, they are both equal to X. A is equal to B2, sum of angles in a triangle. Now we have put up the information and we have concluded that triangle BDE and triangle CDB are equal to each other. That's my answer for number 1. Keep in mind that when two triangles are equal to each other, they can form equivalent fractions. But that's not what we are doing right now. We have answered the question as is required. Number 2, we want to find the value of BD. Now, if we check in our diagram, we can see that BD is a part of the ratio that the question has given us. So that is something we may need to look at. BD, we are told that AD is equal to 15. Now, AD is 15, and at the same time, we have been given the ratio AD to DC. So the line from A to D and D to C, that is equal to 15 to 3 and 2. Now, using that ratio, we can calculate the value of DC. So if we replace A with 15, then we are left with D here. We can use even grade 9 ideas of ratios and fractions to simplify this. So DC is equal to 10. Now we have 10 units in place of DC. Let's go on and find out why is BD connected to those lines. In the similar triangles that we proved in question 1, the value of BD divided by the line DA is exactly the same as CD divided by the line DB. This comes from similar triangles. Then we can cross multiply BD times BD. That gives us BD squared is equal to AD times CD. Then the line AD is given and the line CD is also given. AD is equal to 15 and CD is equal to 10. Therefore, BD squared is equal to 15 times 10, which is equal to 150. Now, BD is the square root of 150, which is equal to 5 times root 6, because the instruction, or it didn't say we must leave our answer in said form. I have expressed in said form, but if you are not instructed to do so, then you can express your answer to 2 decimal places. We have answered number 2. My working out is a bit long. I just did not want to create confusion by making it too short. But otherwise, once you understand this, you can express your answer very much fast. This is a geometry question. You can see how we developed the question here. From having two angles that are equal, that led us to parallel lines. Then the parallel lines brought with them corresponding angles, and then we added in the idea of angles in the triangle add up to 180, and that helped us compile the answer for this question. So it is important to read and understand what the question is talking about before attempting the answer. That is our geometry question. Okay, let's have a look at the next question that we need to answer, which is question number 3. Right, answering the third question becomes way much easier, even though it looks like it's a lot because it's 6 marks. It looks way much easier, way much difficult because of the number of marks. But in terms of what we have already done, we can see that we are almost there. All right, so the answer for this question now for number 3, in triangle ABD, in triangle A, B, and D, that triangle there, that is a right angle triangle. And in a right angle triangle, we can apply the theorem of Pythagoras. So in that triangle, we have to find the value of AB. So AB squared, if you look at the diagram properly, triangle ABD, we notice that the right angle in this triangle is at point D. So this is our right angle. Therefore, on the opposite of BD, that is where we find the hypotenuse of the triangle. Therefore, we can say that AB squared is equal to BD squared plus 15 squared. That is the theorem of Pythagoras. Then BD is already there from our previous calculation, and then BD is already there from our previous calculation. It's the square root of 150. We calculated this in number 2. Then the value of AD is given. It is equal to 15. So we can use theorem of Pythagoras in that case and square these two sides, and that will give us the length of line A to B. Then we know that the value of E1 is equal to 90 degrees. It is also equal to the value of ABC. We have already figured out that one. This is E1 is 90 degrees, and the value of B, angle B, B1 plus B2 combined, is also equal to 90 degrees. That information is already given. Now, we have already established that the line BC is parallel to DC. The idea is that of corresponding angles. And because of the parallel lines, line DE and line BC, we can apply the proportionality theorem. The proportionality theorem is applicable each time we have a triangle in which there is a line drawn which is parallel to one side of the triangle. So line from A to E divided by line from A to B. It must equal line from A to D divided by line from A to C. The reason is proportionality theorem, BC is parallel to ED. Then we can carry on there and do our substitution. Do substitution, cross multiply, and get the value of AE. So please, just a question, I forgot to write the reason here. Proportionality theorem, then you must state the lines that are parallel in the diagram. It is a requirement, please. So after writing proportionality theorem, we need to say that the line BC is parallel to the line ED. Then my answer is now complete. I have calculated the value of AE as is required by this particular question. Thank you very much for watching. Thank you for subscribing and for encouraging all your friends and brothers and sisters to do the same thing. If you need any help, if you need any more information, if you need notes, if you need examples, if you need anything to do with mathematics, you are very much welcome to contact me. Drop me an email, drop me a WhatsApp, or call me. Then let's see how we can help each other Thank you very much. God bless you. Continue working and God bless your dream.